Hi, back with me again. So for now, I will introduce some introduction of the HPLC or High-Performance Liquid Chromatography. So what is HPLC? HPLC or High-Performance Liquid Chromatography is an analytical technique to separate, identify and quantify the component in the mixture, including non-volatile and thermally unstable compound. Here are some overview of the HPLC process. The solvent used to separate component in a liquid sample for HPLC analysis is called the mobile phase. The mobile phase is delivered to the separation column, otherwise known as the stationary phase, and then to the detector at the stable flow rate controlled by the solvent delivery pump. A certain amount of sample is injected into the column and the compound contained in the sample are separated. The compounds separated in the column are detected by the detector downstream of the column, and each compound is identified and quantified. Because of HPLC is versatile, HPLC is used in a variety of industrial and scientific applications such as pharmaceutical, environmental, forensic, and chemicals. Next, I will talk about the advantages and disadvantages of the HPLC. The first one is efficiency and accuracy. Compared to other chromatography techniques such as TLC, HPLC is extremely quick and efficient. It uses a pump rather than gravity to force a liquid solvent through a solid absorbent material with different chemical compounds separating out as they move at different speed. The process can be completed in roughly 10 to 30 minutes and it delivers high resolution. It is accurate and highly reproducible. Next is sensitivity and resolution. In general, HPLC is versatile and extremely precise when it's come to identify and quantifying chemical compound. With many steps involved, the precision of PLC is largely down to the process being automated and therefore highly reproducible. Despite its advantages, HPLC can be costly, requiring large quantity of expensive organic.
Methodology: sample preparation. First, vanilla sample from Kemiling South Lampung, about 1.5 kg, were cured by 3 methods. First is scalding in hot water at 65 Celsius for 30 seconds. Second, drying in the oven at 16 Celsius for 48 hours. Lastly, drying in the sun for 20 days and 2 to 3 hours every day. Extraction procedure. First, extract the pure vanilla operate extraction in the saltlet extraction apparatus with 200 ml of the ethanol for 60 hours. Then transfer it into the 250 ml volumetric flask. Rinse the flask of the extraction apparatus several times with small quantity of ethanol and pour the washing into the volumetric flask. Make up it to the mark with the ethanol and mix it well. Then, extract the pure vanilla operate extraction in the percolation apparatus, which is known as Erlenmeyer, and submerge about 35 ml of the ethanol in Erlenmeyer for 1 night. Then, transfer it into a volumetric flask through a paper filter. The paper filter was filled with ethanol, and this paper filter was stored to use at the second filtering. Then, result of the pure vanilla from the first submerge was found in mortar. Then it was submerged again about 35 ml of the ethanol in Erlenmeyer again for 1 night. After submersion for 1 night, ethanol from the second submerge will fuse with the first one through the filter by using a filter paper which we used at the first filtering. Then rinse the pure vanilla with ethanol and pour the washing into volumetric flask. Make up it to the mark with the ethanol and mix it well. Lastly is the preparation of standard solution. The standard solution containing 0.5, 1.0, 2.0, 3.0, and 5.0 ppm of each standard were prepared in ethanol for HPLC. Then the solution was stored at -2 Celsius until it was required for analysis. The standard solution for spectrophotometry containing 1.0, 2.0, 3.0, 4.0, and 5.0 of ppm of each standard were prepared in ethanol. Then quantification of vanillin content. So vanillin content can be found by multiplying concentration of standard solution from calibration curve at HPLC or by using spectrophotometric method by an initial value of solution. Then divide it with the sample weight and multiply it with 100%.
My name is Hanizawani binti Muhammad Qasim, and next we will talk about the results. From the tables, we know that the linear regression equations and the correlation coefficients of the peak area measurements for vanillin stranded in HPLC techniques and the absorbance in the ISO spectrometric assay methods are shown. The linear relationship were observed for vanillin standard between 0 and 4 ppm using HPLC, with correlation coefficient of 0.997 and between 0 and 5 ppm using UV spectrometric technique with correlation coefficients of 0.999. And from the table 2, the amount of vanillin obtained by HPLC and the ISO spectrometric assay method for the 12 samples is shown. Statistical study of utilizing variance analysis ANOVA reveals that the treatments of X1, X2, X3, and vanilla sample 0.1, 0.2, and the extraction methods of Z1 and Z2 all have an effect on the vanillin concentrations of vanilla. This occurs in both the HPLC and spectrometric methods. The HPLC analysis was used to investigate the recovery process. The concentration of vanillin standard is 3.5 ppm based on the amount of vanillin standard required. As a result, the recovery procedure obtained can be calculated to be 99.77%. This result indicates that the method used to determine the concentration of vanilla using HPLC is adequate for the following measurements.
Spectrophotometric assay consistently generates higher values than HPLC approach for 12 vanilla samples examined. Vanillin is not pure to combine with other components and absorbs at same wavelength area, so the result must be high level of absorption. HPLC uses a UV detector, which is samples can be separated before it reaches detector cells by passing via C18 column. Result must be a smaller particle of vanillin. This method more accurate. If sample, which is specific chromatography column, is separated first, UV spectrophotometry can be more accurate. Result of this method yields equal to HPLC method, with a standard deviation less than 1%. The amount of vanillin obtained by ISO spectrophotometric test for 4 samples higher than those determined by HPLC.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Fatimah binti Salahuddin, and today in High-Performance Liquid Chromatography, I will present about the discussions. Okay, based on the result in the table, we can see that there is an impact among the treatment of X1, X2 and X3. A vanilla sample which is Y1 and Y2, and the extraction method which is Z1 and Z2 toward vanillin content in the vanilla. This is usually occurs in high-performance liquid chromatography method and in the spectrophotometric method. high-performance liquid chromatography analysis has been used to investigate the recovery process of vanillin content in the vanilla samples. The concentration of the vanillin standard that was used is 3.5 ppm based on the amount of the required vanillin standard. The analytical result of the investigation are 3.49, 3.51, 3.48, 3.48, 3.50 and 3.49 ppm respectively, and the average of the results is 3.49 ppm. Thus, the recovery process that was obtained is 99.77% and shows that the method that we use, which is high-performance liquid chromatography method, is sustainable for the next measurements. That's all from me. Thank you.
The conclusions of high-performance liquid chromatography. Since there is perfect contact between the vanillin component in the vanilla sample and the extraction solvent, the pre-extraction procedure for pure vanilla cut around 2.5 cm resulted in 80 vanillin concentration. The vanillin content obtained from the solution extraction is greater than that obtained from the percolation extraction. This occurs because the solvent purification procedure in the solution extraction is ongoing. As the outcome, the density of vanillin in vanilla extract is high. The high-performance liquid chromatography approach is more accurate than the isospectrophotometric assay for detecting the vanillin concentration of vanilla because the vanillin is isolated from other chemicals under the LC method.